Problem 4-75. Marvelous Mark's function machines. Mark has set up a series of 3 function machines that he claims will surprise you. Letter A. Try a few numbers. Are you surprised by your results? Then letter B. Carrie claims that she was not surprised by her results. She also says that she can show why the sequence of machines does what it does by simply dropping in a variable and writing out step by step what happens inside each machine. Try it. Says, little hint, use something like C or M. Be sure to use all of the steps. Or, I'm sorry, show all of your steps. I can't read. So, here we go. Marvelous Mark. You're probably a pretty awesome individual. This is Marvelous Mark. Let's see what happens. Let's just throw some numbers in there. How about if I throw a 5 in? Let's throw 5 in. Let's name these functions first. Let's call this f of x right now. F of x equals x minus 5. We've got here, let's call this g of x. G of x equals the 6x plus 8 over 2. And let's call this h of x. That's fun. So we have h of x equals x plus 11 over 3. So to start out, we're going to put in a value and then we're going to get something out. We're going to take that and plug it in. So let's choose a value. Let's say 5. That sounds like a great number to use. So we're going to start here. Let's say the function f of 5 is going to equal, and we're plugging in 5 for our x, so we have 5 minus 5. So our f of 5 should equal 0. So that is our output of our function there. We put 5 in, we got 0 out. We're going to take that 0 now and plug it into the next part of it. So we have g of 0 equals 6 times 0 plus 8 over 2. 6 times 0 is 0, plus 8 is 8. 8 divided by 2. Oops, got a little ahead of myself there. 8 divided by 2, not 4. Oh, that's just awful. Third time's a charm. 8 divided by 2 equals 4. So we know that g of 0, or when we take the output from the first function, we plug it in as the input, our new output is 4. Let's take now our output and let's plug it in as our input for the last one. So h of 4 is going to equal 4 plus 11 over 3. Well, 4 plus 11 is 15, and 15 divided by 3 is going to give us 5. So we had 5, out came 0, plugged in 0, out came 4, 4 went in, and out came 5 again. I think the thing that they want us to see here is that whatever value we plug in is also going to be the output at the end there. If you want to try some other numbers, go ahead and plug them in there and see if that works for you. It should. So are you surprised by your results? We'll say yes, it was very surprising. Wasn't really surprising to me, but I already knew the answer. Now, Carrie claims that she was not surprised. So let's do what Carrie asked us to do that we read earlier by plugging in a variable inside to see what happens. Let's choose, she wants C or M, or they want C or M, so let's use something else. Let's use, let's use N. N is fun. So for our first one here, we're going to say, and let's change the colors here so we don't get this work all mixed up. I'm going to put in N into the function. So when I take N and I put it in here, I have f of N is going to equal N minus 5. Now this doesn't simplify down anymore, so this is what we're going to have to take and plug into our next function. So we're going to say g of n minus 5, let's say here, this would have been n minus 5 coming out. We're taking that and it's dropping in here. Let's plug it in for our x over here now. So we're going to say g of n minus 5 will then equal 6 times n minus 5 plus 8 over 2. We just plugged our input into the function for where x was. Let's simplify this down. 6 times n is 6n. So we're going to have 6n minus 30 plus 8 all over 2. 6n minus 30 plus 8, well, this is the same thing as 6n minus 22 all over 2. Now you could factor out your 2 and cancel, or you could just reduce that down. You know that 2 goes into both of these numbers, so in order to reduce it, we'd have to do that. But let's just, you know what, let's just factor out the 2. So that would be like saying 2 times 3n minus 11 all over 2, which means that these will give us values of 1. So our g of n minus 5 will end up equaling 3n minus 11. That is the output for this one. So we have 3n minus 11. It now becomes the input into h of x. So let's see here. We're going to say, I'm going to move it over just a little bit. Actually, let's see if we can scroll down just a little bit. There we go. So we're going to say h of our input now, 3n minus 11, should equal, we're going to plug it in for x here. So we're going to have 3n minus 11 plus 11 all over 3. 3n minus 11 plus 11, well, these are additive inverses there, so that's going to give us 0. We're going to have 3n over 3. Now the 3's, this is a monomial, this is a monomial. That means we can reduce it down. They have a common factor, which means we're going to end up with our value of n. So what comes out? N comes out. What did we put in? We put in n, so it still works there. We've just shown it algebraically. So what's super special about what's going on here is whatever value we plug into our function machine, as it works its way all the way through, it will be the same value that comes out. You've seen it with a number, you've seen it with a variable there, just so you know that it works. This is problem 4-75. We're talking about Marvelous Marks function machines. If you have questions, ask your teacher. Go to Math Help, go to Math Lab, whatever it is that you have available to you. This is Mr. Boyd, problem 4-75, signing off.